This meeting is being recorded.
So our next problem that we'll take a look at from chapter 8, number 24, we're asked to predict the major products of each of these reactions. So we have bromination, right, of our alkene, of our pi bond, and we should note that the addition of molecular bromine will follow an anti-addition pattern to our pi bond. So I tried to draw our starting material here minus the pi bond for each of these reactions, because there's a particularly difficult structure to draw with molecule D there with a 7-membered carbon ring. So I tried to save some time by drawing some structures ahead of time. And I also noted that each of these we're going to create at least one chiral center. So we're also going to have the enantiomer with our products here. So for A, when we add bromine to our double bond, we're going to see, so this methyl group is on a wedge, this bromine would be on a dash, and then we would have down here with that methyl group on a dash, this bromine would add on a wedge. So this is our first product plus the enantiomer for molecule A. In molecule B, we're going to create 2 chiral centers, but there's a methyl group on this one, so that one's already drawn in. So we're going to have that on a wedge, and let's put our bromine here on a dash, and then the other end we add molecular bromine on a wedge. And you can see that there's already a hydrogen there, so there are 4 different groups on both of those carbons, so 2 chiral centers. For molecule C, again, the enantiomer will be created, so we know that there's at least 1 chiral center that's created with our product here. So we're going to add bromine over here, but there's 2 hydrogens there already, so that's not going to be a chiral center, but we should designate this addition here on a wedge or a dash. Either's fine, but we need to indicate that that would be a chiral center. So we have plus the enantiomer as our product. And last, we have this larger ring here, this 6-membered ring. So we're going to add molecular bromine across the pi bond here. So I'll try to match that up with our drawing. So on this carbon here, if we put this on a wedge, we would have to put this bromine down here on this carbon on a dash. So again, anti-addition across the pi bond. And if you look in the textbook, it shows you the mechanism and the intermediate that forms, and which prevents a syn addition from occurring. So remember, with molecular bromine, we will always have anti-addition across our pi bond.